Both polyethylene oxide (PEO) and polymethyl methacrylate (PMMA) can be known as polymer electrolytes. Both PEO and PMMA have their own drawbacks, which both suffer from poor ionic conductivity of ambient temperature. So we provided ways on how to increase the ionic conductivity for both PEO and PMMA. In the first part, we discussed the properties of PEO and PMMA. Next, we propose ways to increase ionic conductivity in both PEO and PMMA from various aspects such as adding salt, filler, and plasticizer into both polymer electrolytes. Lastly, we conclude the result that was obtained from this study by taking highest ionic conductivity for both PEO and PMMA along with the best salt, filler, and plasticizer to be used.
Assalamualaikum and hi. Our group will present about ionic conductivity of PEO and PMMA based polymer electrolyte. We will begin this presentation with introduction to polymer electrolyte. According to Ramesh and Lu, polymer electrolyte defined as a membrane consists of dissolution of salt in a polymer matrix with high molecular weight that is widely applied in electrochemical device due to its high ionic conductivity. Polymer electrolyte can be divided into three types, which are solid, gel, and composite. Each and every type of polymer has its own advantages. As we can see in this slide, gel and composite polymer has high ionic conductivity, while gel polymer electrolyte has high flexibility apart of its low ionic conductivity. Next, we moved on to background. According to Nye, in the early of 1970s, polymer electrolyte has gained attention due to its advantages, and the main concern of researchers towards polymer electrolyte is its ionic conductivity. The higher the ionic conductivity, the better the polymer. Thus, many approaches has been done in order to increase the ionic conductivity.
Now I will present about polyethylene oxide. Polyethylene oxide, PEO, is a synthetic, hydrophilic, and biocompatible polyether. It is also known as polyethylene glycol, PEG, or polyoxyethylene, PEO. So, this polymer is soluble in all organic solvents such as ethanol, acetonitrile, toluene, acetone, dichlorobutane, hexane, chloroform, and water. Researchers show interest towards PEO, especially in biophysics and biochemistry. The synthetic polymer consists of two terminal groups, which are hydrogen and hydroxyl. According to Ozame and his colleague, PEO is semi-crystalline bioadhesive and mucoadhesive due to PEO water solubility, hydrophilicity, high viscosity, ability to form hydrogen bonds, and biocompatibility. PEO is a suitable polymer host for composite solid electrolytes. PEO has poor ionic conductivity, which are lesser than 10 to the power of 5 nearest to 10 to the power of negative 6 centi per centimeter of PEO-based solid electrolytes at room temperature. This is due to its high crystallinity of this material, which also causes their mechanical qualities to deteriorate as temperature rises. A variety of modification methods have been proposed in order to enhance the ionic conductivity, thermal and electrochemical stability, electrochemical window, and mechanical properties.
Assalamualaikum and hi, I will continue the presentation by discussing the properties of PMMA followed by the ionic conductivity of PEO. What is PMMA? Polymethyl methacrylate is a methyl methacrylate polymer which the formula C5H8O2N, Colever and D. Petit et al. 2021 reported that PMMA was synthesized using the monomer methyl methacrylate and was discovered in early 1930s by British scientists John Crawford and Roland Hill. According to Colever and D, PMMA is a clear, colorless polymer and also known as acrylic glass or simply acrylic. Here are the advantages of PMMA. Application of PMMA: aerospace, machinery, medical, and architecture industry, Ma et al. 2015. Windows, lenses, and other optical devices, Al-Shamari and Said 2016. This is the chemical structure of PMMA. The ionic conductivity of PEO displayed in this table along with relevant references. The first row showed that adding 30% of LiBF4 to pure PEO-based electrolyte increased ionic conductivity by 8.75 times 10 exponent negative 4. LiBF4 improved crystallinity and surface smoothness, thereby increasing ion mobility. The maximum ionic conductivity of 20% LiPFC is 1.5 times 10 exponent negative 4, as shown in the second row. Next, the maximum conductivity for the third row was 3.35 times 10 exponent negative 5 when 15% LiClO4 was used, which is 4 order higher than pure PEO. The final row show 1.00 times 10 exponent negative 6 conductivity when 15% LiCF3SO3 is added. The first will show that the addition of 5% SiO2 have the highest ionic conductivity, which is 1.10 times 10 exponent negative 6 due to decrease in crystallinity, resulting in more amorphous region. Next, when 1% GO added to PEO composite electrolyte, the ionic conductivity is 2 times 10 exponent negative 5. Third row shows the maximum ionic conductivity of PEO, PVP, and ALO4 composite electrolyte filled with 3% TiO2. The sample PEO system with 0.05 ZrO2 had the highest conductivity, 1.38 times 10 exponent negative 4. The sample containing 5% MgO had a maximum ambient temperature ionic conductivity value of 2 times 10 exponent negative 6. The addition of 15% alumina increased the ionic conductivity of PEO9 LiClO4 from 2.03 times 10 exponent negative 6 to 7.62 times 10 exponent negative 6. The addition of 5% ZrO2 into the PEO-based composite system have highest ionic conductivity, 6.96 times 10 exponent negative 5, due to the creation of the additional sites and favorable conduction pathway for ionic transport via Lewis acid-base star interaction between the polar surface group of the ceramic filler and the electrolyte ionic species. The ionic conductivity of PEO-based composite system was significantly improved by adding CEO2, which is 2.15 times 10 exponent negative 3. The maximum ionic conductivity, which is 10%, and IO is 7.4 times 10 exponent negative 4. Inorganic filler enhanced amorphous electrolyte, facilitating lithium ion transfer from LiCF3SO3. The ionic conductivity of PEO, LiTFSI, and electrolyte embedded with 5% alumina is at its peak, which is 3.3 times 10 exponent negative 4 due to the composition's maximum amorphous phase.
Sharma and Singh studied the influence of high and low dielectric constant plasticizer on the ion transport properties of PEO with ammonium bifluoride with concentration of 10% as a polymer electrolyte and propylene carbonate PC, dimethyl acetamide DMA, dimethyl chloride DMC, and diethyl carbonate DEC as plasticizers that were prepared by solution casting technique. Plasticized polymer electrolytes containing 0.3 ml of propylene carbonate PC for retaining mechanical stability and flexibility have been found to have a maximum ionic conductivity of 1.4 times 10 to the power of negative 4 SCM-1 at ambient temperature. Longkan and Pumchusak carried out an experiment to study the effects of nanoalumina and plasticizers on ionic conductivity of PEO mixed with lithium triflate solid polymer electrolyte. Host matrix for the SPE was PEO doped with 15% lithium triflate. Aluminium oxide nanoparticles were used as a filler, and polyethylene glycol (PEG) and dioctyl phthalate (DOP) were used as plasticizers. Significantly, the ionic conductivity of PEO mixed with lithium triflate solid polymer electrolyte was increased to 10 to the power of negative 5 and 10 to the power of negative 4 SCM-1 respectively, with the addition of 20% DOP and nanoalumina. Tawala and others worked on an experiment to observe the effect of plasticizers, EC or PC, on the ionic conductivity and thermal properties of the PEO mixed with lithium triflate mixed with aluminium oxide nanocomposite polymer electrolyte system. In the experiment, PEO mixed with lithium triflate was used to be dispersed with ceramic filler, which is aluminium oxide, and plasticized with propylene carbonate PC, ethylene carbonate EC, and a mixture of EC and PC. A mixture of plasticizer EC and PC further demonstrated the greatest conductivity improvement in the targeted temperature range, yielding a value of 1.2 times 10 to the power of negative 4 SCM-1. Quilla and others applied the solution casting technique with perovskite type lanthanum manganate as a nanofiller and polyethylene glycol PEG as a plasticizer and successfully created an interesting PEO composite polymer electrolyte. It continues to rise when the PEG concentration in the PEO mixed with sodium perchlorate mixed with 10% lanthanum manganate increases, reaching a maximum value of 2.6 times 10 to the power of negative 4 SCM-1 for 30% PEG-based composite polymer electrolyte.
We continue to discuss on ionic conductivity of solid polymer electrolyte with PMMA as polymer host by reviewing experiment conducted by respected researcher. Shukla and Tako conducted an experiment on PMMA with lithium perchlorate through optimization of salt concentration. Highest ionic conductivity recorded from this experiment reached 6.07 times 10 to the power of negative 9 with 21% of lithium perchlorate salt concentration. Next, PMMA as polymer host and lithium iodide used as salt in second experiment conducted by Zulkifli and others by using solution casting method. In room temperature, ionic conductivity of the system reached 4.37 times 10 to the power of negative 6. Experiment number 3. Conducted by Ramesh and Wong, recorded highest ionic conductivity, which is 9.88 times 10 to the power of negative 5, using 63/35 ratio of lithium triflate and PMMA as polymer host. They claim that these ionic conductivity recorded are acceptable for manufacture of phone batteries. Last experiment reviewed is conducted by Kurapati and others. They studied on solid polymer electrolyte with PMMA as polymer host and lithium acetate as salt. Same as experiment 3, different weight ratio used, and they conclude ratio 60/40 recorded highest ionic conductivity, which is 8.21 times 10 to the power of -5. Table below shows overall reviewed experiment. For solid polymer electrolyte with PMMA as polymer host, experiment number 4 shows highest ionic conductivity recorded using lithium acetate as salt.
Okay, now we will continue about the ionic conductivity in gel polymer electrolyte using PMMA as the polymer host. According to Rizzuto and his colleague in 2022, they studied about the PMMA-based gel polymer electrolyte using PMMA as the host polymer, lithium perchlorate, propylene carbonate, and a mixture of propylene carbonate and ethylene carbonate in molar ratio of 1:1 plasticizers. They investigated the effects of different plasticizers on the characteristics of gel polymer electrolytes at room temperature. The highest conductivity was observed for PMMA LiPC at 0.5 molar salt concentration, which is 3.43 times to the 10 of -3, while the highest conductivity was observed for PMMA LiPCEC as 1.0 molar salt concentration, which is 3.1 times 10 to the power of -2 cm/centimeter. The interactions between lithium ions, solvent molecules, counter ions, and polymerate chains increased as salt concentrations increased. According to MZ Kofian and his colleague in 2021, they studied PMMA lithium trifluoromethane sulfonyl amide LiTFSI based gel polymer electrolytes using this salt as the lithium ion donor and tetraethylene glycol dimethyl ether TEGDME as the solvent. The highest conductivity sample is 2.80 times to the 10 to the power of -3 and was made up of 25 weight percentage for LiTFSI. PMMA has strong lithium metal interfacial stability, this making it a focus of research. Gel polymer electrolytes offer higher electrolyte contact stability and stronger ionic conductivity than solid polymer electrolytes. Increasing cationic transference number is an efficient way to boost cationic conductivity, which can be achieved by choosing a lithium ion donor with a larger anion radius. Okay, next we move on to the ionic conductivity of composite polymer electrolyte. Ramesh and Liu Chiang Wang in 2023 studied about the composite polymer electrolyte using polymethyl methacrylate, which is PMMA, as the host polymer. They found that PMMA has a flexible backbone and amorphous phase, making it an ideal dopant salt. Ramesh and Liu Qiawen in 2023 found out that the highest ionic conductivity in the CPA is 7.3 times 10 to the power of -5 when there was addition of 2 weight percentage of silicon oxide. In the current study, the impacts of dispersing nano-sized fumed silica onto the composite, PMMA, lithium trifluoride, and silicon oxide system in the absence of plasticizer increase the ionic conductivity of polymer electrolyte at the room temperature. Therefore, lithium trifluoride as a dopant salt and nano-sized fumed silica SiO2 as an inorganic filler increase the ionic conductivity of the composite polymer electrolyte at the room temperature. Next, Sun and his colleague in 2018 studied the impact of inert fillers on PMMA-based composite polymer electrolyte using a solution casting technique. They prepared PMMA, lithium trifluoride, ethylene carbonate, and aluminum oxide composite polymer electrolyte. Sun and his colleague in 2022 also studied about PMMA-based composite polymer electrolyte containing lithium trifluoride salt, ethylene carbonate plasticizer, and silicon oxide as filler, revealing higher ionic conductivity of silicon oxide particles. Therefore, they found that at 15 nanometer of aluminum oxide had the highest ionic conductivity at room temperature, which is 1.52 times 10 to the power of -4 cm/centimeter.
The ionic conductivity of PEO and PMMA was improved by different approaches, such as using various salt, nanofiller, and plasticizer. For PEO, in the category of salt, by adding 30% lithium tetrafluoroborate to PEO, it produced highest ionic conductivity among all of other salt, which is 8.75 times 10 to the power of -4 SCM-1. Due to amount of lithium tetrafluoroborate in the PEO decrease the crystallinity of the electrolytes, producing smooth surface of the electrolyte and promotes ion mobility, hence enhancing the ionic conductivity. Next, in the category of failure, highest ionic conductivity obtained was 2.15 times 10 to the power of -3 SCM-1 by adding 20% of cerium dioxide to the PEO mixed with potassium iodide system. This is because of the epithelial effect of cerium dioxide nanoparticles that plays a significant role in affecting the ionic conductivity. Furthermore, by adding 20% diethylphthalate DOP as a plasticizer along with nanoalumina into PEO mixed with lithium triflate system, it produced the best ionic conductivity, which is 7.6 times 10 to the power of -4 SCM-1 due to the addition of DOP plasticizer and nanoalumina that decreases the crystallinity of the electrolyte. For PMMA, the salt that gives the highest ionic conductivity is lithium triflate, which is 9.88 times 10 to the power of -5 SCM-1. Lithium triflate was combined with the PMMA to have maximum conductivity, which is suitable for the application of cell phone batteries. Besides, by mixing the propylene carbonate and ethylene carbonate in molar ratio 1:1, PMMA mixed with lithium salt, mixed with propylene carbonate PC with ethylene carbonate EC plasticizers into PMMA based gel polymer electrolyte GPE on the PMMA, lithium perchlorate. The ionic conductivity for PMMA mixed with lithium salt mixed with PC and EC is 3.1 times 10 to the power of -2 SCM-1, which is the highest ionic conductivity among the discussed gel polymer electrolytes. It was discovered that the system had an unreacted PMMA monomer which seemed to improve ionic conduction. Other than that, the highest ionic conductivity for the PMMA-based composite polymer electrolyte is 1.44 times 10 to the power of -4 SCM-1, where the size of silicon dioxide is 10 times 10 to the power of -6 m. Thus, it can be said that in the polymer electrolyte system, by reducing the filler size leads to smaller particle size, which can increase ionic conductivity, resulting from reducing the porosity structure of polymer electrolytes and encouraging lithium plus ion mobility. To summarize the result for PEO, the most ideal is lithium tetrafluoroborates as a salt, cerium dioxide as a filler, and diethylphthalate plasticizer that can be used to enhance ionic conductivity. Meanwhile, for PMMA, the most suitable salt is lithium triflate, silicon dioxide as a filler, and mixture of propylene carbonate and ethylene carbonate PC and EC as a plasticizer that gives the best ionic conductivity.
Lastly, we moved on to conclusion. This review has been studied through all types of polymer electrolyte. Finally, based on our review, we can conclude that PEO-based polymer electrolyte is the best polymer host compared to PMMA in terms of its flexibility, ionic conductivity, and safety. That is all from us. Thank you.
Now I will continue to the Q&A session. Given the question is, conductivity and mechanical strength are among the important properties of polymer electrolytes. Describe various techniques to improve the properties of polymer electrolyte. So based on our studies, we found 3 techniques to improve the properties of polymer electrolytes, which are, firstly, we can do the polymer matrix modification by blending different polymer and add plasticizer or fillers into the polymer. Secondly, we can use the ionic liquid incorporation technique, which is we doping organic salts that are liquid at the room temperature. So for example, we can use the lithium triflate and ammonium triflate as the doping salts. So for the third techniques is nanostructured filler. By adding nanostructured filler, as it can provide a higher surface area. For example, nanostructured filler is graphene oxide. Other than that, there are another 5 of techniques to improve the properties of polymer electrolytes. There are cross-linking, solid-state polymer electrolytes, surface modification, composite electrolytes, and hybrid polymer electrolytes. That's all from us. Thank you.